Hello my dear students, let us solve some more numericals on shear strength of soil. Let us take this example. The effective strength parameters for a fully saturated clay are known to be C dash equal to 15 kilonewton per meter square and phi dash is equal to 29 degree. In an unconsolidated undrained triaxial test on a specimen of the same clay, the all-around pressure was 100 kilonewton per meter square and the principal stress difference at failure 170 kilonewton per meter square. Assuming that the above parameters are appropriate to the failure stress state of the test, what would be the expected value of pore water pressure in the specimen at failure? Okay, here it is asked to calculate the pore water pressure. So here effective strength parameters are given, that is C dash is equal to 15 kilonewton per meter square or 15 kPa and phi dash is equal to 29. Why this dash and dash, C dash, phi dash? Because it is effective strength parameters. Effective strength is always the total this minus pore water pressure and is represented by C dash and phi dash. Okay. Now, this is unconsolidated undrained triaxial test, means UU test. Okay, here sigma 3, that is given all around pressure, that is nothing but cell pressure, is equal to 100 kPa and principal stress difference at failure. Principal stress difference means sigma 1 minus sigma 3. That is the difference it is asked. Difference between the principal stress. That is sigma 1 minus sigma 3 is equal to 170 kPa. Then, so we know sigma 3 is equal to 100. Sigma 1 minus sigma 3 is equal to 170. So, sigma 1 is equal to 170 plus 100. That is 270 kPa. Now, it is asked to calculate pore water pressure. So, first you have to calculate, you know this formula. Sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. This is in terms of effective stress. So, sigma 1 dash is equal to sigma 3 dash into tan square 45 plus phi dash by 2 plus 2c dash tan 45 plus phi dash by 2. Now, what is sigma 1 dash? That is nothing but sigma 1 minus u. You have to deduct the pore water pressure from this normal stress. Mine is equal to sigma 3 dash is sigma 3 minus u into tan square alpha is 45 plus 5 by 2. So, here 45 plus 5 dash is given, that is 29. 29 divided by 2, that is 14.5. Plus 2 into C dash is equal to 15 given into tan 45 plus 5 by 2. So, you get here sigma 1 is equal to 270. So, 270 minus u, that is equal to 100 minus u into tan square. Simplify this into 2.88 plus 2 into 15 into tan of this is 1.7. Simplify, only one unknown, that is u. So, when you simplify this, you get u is equal to 36.7 kPa. So, like this, you can calculate what is the expected value of the pore water pressure in the specimen at failure. Okay, I hope all of you understood. Very simple. Main thing you should know all the terms, like if it is unconsolidated undrained test, then what is sigma 1, what is sigma 3 and what is C and what is phi. It is given here. So, and also this formula you should always remember. And if it is in the case of effective strength, you have to deduct the pore water pressure, that is nothing but U. So, you can get the answer. I hope all of you understood. Let us take one more example. In an unconfined compression test on a saturated clay, the undrained shear strength was found to be 55 kPa. If a sample of the same soil is tested in an undrained condition in triaxial compression at a cell pressure of 200 kPa, then what will be the major principal stress at failure? Okay, here it is given unconfined compression test on a saturated clay. The shear strength is equal to 55. That is nothing but Cu, undrained shear strength, that is unconfined compression test. So that is Cu, that is equal to 55 kPa. And for undrained test on saturated clay, that is phi is equal to 0. This is fully clay, only C value will be there, friction is not there. So that is why phi u is equal to 0. Okay, now we have this formula, sigma 1 minus sigma 3 divided by 2 is equal to Cu. Okay, this is the formula. Now sigma 1 we have to calculate, because it is asked to find what will be the major principal stress at failure. Major principal stress is sigma 1 and minor principal stress is sigma 3. So sigma 1 is equal to cross multiply 2 Cu plus sigma 3. 2 Cu, 2 into Cu. Cu is 55, 2 into 55 plus sigma 3. Sigma 3 is equal to 200. It is given compression, cell pressure. Pressure is sigma 3, that is equal to 200. So totally sigma 1 is equal to 310 kPa. So very simple example. Only you should know when it is undrained shear strength, that is Cu, and for that formula Cu is equal to sigma 1 minus sigma 3 divided by 2. For this case phi is equal to 0, because it is saturated clay, there is only cohesion, there is no friction, so friction is equal to 0. So you will get this answer. Okay, let us take this example. A sample of dense sand in a triaxial CD test failed along a well-defined failure plane at an angle of 66 degrees with the horizontal. Find the effective confining pressure of the test if the principal stress difference at failure was 100 kPa. Okay, now what is given here? This is a dense sand subjected to CD test. So it is a sand, so dense sand, so there is cohesion is not there, only friction here. So and this C dash is equal to 0. Okay, next, because why this is C dash, it is asked to find the effective confining pressure. Effective means always you have to use C dash, phi dash, sigma dash, like that. So now this C dash is equal to 0, because it is a dense sand, there is no cohesion, only friction. Next, well-defined failure plane inclination with respect to horizontal, that is alpha. Okay, well-defined failure plane at an angle, that is alpha, equal to 66 degree. We know alpha is equal to 45 plus phi by 2. In this case 45 plus phi dash divided by 2. So that is equal to tan alpha. Tan alpha is equal to 45 plus phi by 2. So substitute this alpha is equal to tan alpha is 66. So you will get what is phi. So 66 into 2 minus 45. So that is equal to phi dash, that is equal to 42 degree. Now this is given here, the principal stress difference, that is nothing but sigma 1 minus sigma 3. So here it is effective. So sigma 1 dash minus sigma 3 dash, that is equal to 100. We have formula sigma 1 dash is equal to sigma 3 dash tan square alpha plus 2c tan alpha. Here c equal to 0, because it is a dense sand, so this term becomes 0. So only this two terms will be there, that is sigma 1 dash is equal to sigma 3 dash into tan square alpha is 45 plus 5 by 2. So 45 plus 5 is 42. So 42 divided by 2 plus 45. So you get sigma 3 into tan square 66. Simplify this, you will get sigma 1 dash is equal to 5.04 sigma 3 dash. Okay. Now if you have equation sigma 1 dash minus sigma 3 dash is equal to 100 and sigma 1 dash is equal to 5.04 sigma 3 dash. Substitute sigma 1 dash value in this equation 1. Okay. So you will get what is sigma 3 dash, that is equal to 24.75. So Once if you get what is sigma 3 dash, you can calculate what is sigma 1 dash also, but it is just asked to calculate what is the effective confining pressure. Confining pressure is nothing but sigma 3, and this is effective confining pressure. So sigma 3 dash is equal to, you will get 24.75 kPa. Okay, I hope all of you understood. Very simple. Next, let us see some one more test, that is vane shear test. It is nothing but a field test. Okay, vane shear test is a quick test used to determine undrained shear strength of cohesive soils. The equipment essentially consists of a 4 high tensile steel plates called vanes, which are welded or welded thoroughly to the bottom end of the steel rod called the torque rod, with an arrangement to measure the torque and rotation. This is the field test. Okay, here it mainly consists of 4 high tensile steel plates, that is vanes, okay, which are welded and attached to the steel rod. So that is called torque. With an arrangement to measure the torque and rotation. And here a typical arrangement consists of a calibrated torsion spring attached to the top of the torque rod, which is rotated by a combination of gear and wheel. Okay, so this is the setup of vane shear test. The vane shear test can be conducted both in the laboratory and in field. A typical laboratory set of vanes has 20 mm height diameter and 12 mm across vanes with blade thickness of 0.5 to 1 mm. And usually the field set of vanes of size 100 to 200 mm in height and 50 to 100 mm in diameter and blade thickness of 2.5 meter. And here to conduct the test, the vanes are gently pushed into the soil and the torque rod is rotated at a uniform rate of usually 1 degree per minute. The torque T corresponding to the angle of rotation T at an uniform interval are noted. Okay, here this is the formula to calculate. If T is the maximum torque applied at the head of the torque rod to cause the failure, it should be equal to the sum of the resisting moment of the shear force along the side surface of the soil cylinder and the resisting moment of the shear force at each end. So that is nothing but total torque, that is equal to Ms plus Me plus Me, two ends are there. So when you simplify this, you will get M is equal to Ms is equal to, this is surface area, this is moment arm. So you will get this equation. This variation shear strength mobilization are here. This is shown in the figure, and the torque, not I, this is T. The torque T that is can be expressed by this formula. T is equal to pi Cu d square h divided by 2 plus b into d cube divided by 4. So Cu is equal to, this is the formula to find the shear strength of the soil using the vane test, field test. T divided by, this is the formula to find that. Okay, let us take this formula, direct substitution. A field vane shear testing instrument, the diameter is given 50 mm and 100 mm height, was inserted completely into deposit of soft saturated silty clay with the vane rod vertical such that the top of the blades were 500 mm below the ground surface. Okay, so here it is given the torque is 5.2 Newton meter. Okay, and it is asked to find what is the undrained shear strength of the soil. Okay, now diameter is given, that is 50 mm, and height of the vane, that is 100 mm. Then applied torque T, that is equal to 5 Newton meter. We use the formula when the top end of the vane completely shear the soil, the torque of the failure is given by this formula. T is equal to Cu phi into d square h by 2 plus d cube by 6. When you write in terms of Cu, that is equal to T divided by pi into d square h by 2 plus d cube by 6. Substitute the values. T is equal to 5.2 into 10 raised to 9, convert into kPa, kilo meter into 10 raised to 9, pi into Substitute d square 50 square into 100 divided by 2 plus 50 cube divided by 6. Simplify this. You will get 11.35 into 10 raised to 3 Newton per meter square. That is nothing but 11.35 kPa. Direct substitution. Very simple. I hope all of you understood. Thank you.